marting, types of data mart. Okay, let's discuss what is this data mart and what are the types of data mart. Data mart is nothing but it's a subset of an enterprise data warehouse. A data mart is a subset of an enterprise data warehouse. It's a subset of an enterprise data warehouse. Okay, so it's a subject-oriented database. Let me write down, then I'll explain. It's a subject-oriented database which provides the business needs of department-specific business managers. Which provides the business needs of department-specific business managers. Department-specific business managers. Okay. This data mart, we even call it as HPQS. It's also known as HPQS. HPQS is nothing but high performance query structure. We even call it as HPQS. Okay. Here we have two types of data marts. What are the two types of data marts? We have dependent data mart and independent data mart. Okay. Before explaining more in detail about this data mart, let me give you a very simple example. Let us think. We have some. Let us take my example. Like for example, I'm working in a company like oil and gas company. Let us think. Okay. So they have their oil and gas in various places. They have their oil and gas in US. They have their oil and gas in Italy. They have their oil and gas in India. They have their oil and gas in Australia. Okay. They have in various places. So what they used to do at the end of the day, this is the databases, and they used to load the data into the data warehouse. We used to use different business logics, and we used to load the data into the data warehouse. Okay. So when loading the data into the data warehouse, they have scheduled it. How they have scheduled every day at 9:30 a.m. Like here, they have scheduled it every day at 9:30 a.m. According to a US time zone, the data should get loaded. According to US time zone, the data should get loaded into the target. This is how they have scheduled it. Okay. So when they have scheduled it, what's happening in the data warehouse? Only the exact data, because as you're aware, there are different time zones. For Italy, there is a different time zone. For India, Australia, there are different time zones. It's not same as US time zone. So what's happening? The Italy users or the India users or the Australia users, they are not able to see the accurate data. They're not able to see the accurate data in the data warehouse. Whereas only the US end users are able to see the accurate data because of the scheduled time zone. So what they have asked is the Italy users, they want the exact information. That means day-to-day transactions, whatever is happening, how much records are being loaded, who are the new employees who's coming in, how many gallons of oil has been sold. Everything they want day-to-day transactions, but they're not able to see the accurate results. Because of the US time zone, whatever we have scheduled. So what we have done here, we have taken the data warehouse as the source, and we have started developing small data marts. That means the entire data warehouse we do, and the Italy people, if they wanted, we have scheduled according to Italian time zone. They have scheduled according to their local time zone, Italy time zone, so they're able to see the accurate results in the data mart. So all the accurate results of the Italy information is in this Italy data mart. Similarly, if you take the Australia information also we have scheduled it at 9:30 Australia data, we have scheduled it. So what we have happening, only the Australia people are able to see this data mart, Australia data mart information. So the end users have stopped facing any problems here. Okay, we're able to understand. See here, first what's happening, we are working for a project, oil and gas. Let us think this oil and gas has been in various regions. It has been in US, it has been in Italy, India, and Australia. So what they have done, when they're loading the data into the data warehouse, they have scheduled according to US time zone. That at 9:30 a.m. EST, the data should get loaded into the data warehouse. But we are having one issue here. What is the issue? The Italy users or the India users or the Australia users are not able to see the accurate result in the data warehouse. Why they are not able to see the accurate results? Because of the time zone. Maybe and we have scheduled it in their local time zone. So they are able to see the accurate result, whatever they wanted into the data warehouse. So we have removed this. We have removed this from here. We have removed this from here. So whatever the information we have from the source, all the data will be loaded into data warehouse. And from the data warehouse, we started scheduling in their local time zones and sending to small data marts. This is one example. What is the reason for going for data mart? Clear?
Chaitanya here. So data warehouse is going to be another database, right? Like Teradata or database or Oracle, DB2,
Yes.
right?
Yes, it can be. Yes, it can be another database.
Okay.
Yes, rather, you're right.
Okay, thanks.
Okay.
So first you load it to the data warehouse at 9:30 local time and then go to the data mart? Is that...
No. If you are loading at the local time zone, we are having some issues, right?
Right. No, what I mean is that each country's local time.
Yes. Each country's local time. Yes, you're right.
So that means you first go to the source system, you pull the data, and then it goes to the data warehouse, and then it goes to the data mart. Is that right?
Yes, you're right.
Okay.
So that means it is.
So why would you have why would you create a data mart itself so that, because the data is there in the data warehouse for the local folks, right? I mean, if they log in, let's say it's someone in India, they know that the data is going to be there at 9:30. Then why do we need to create another whole segment in the data warehouse, like data mart? Is it to control the data and what they do with that data?
Yes, in order to control.
Okay.
Because every time, the business logic, whatever we are applying for all the countries may be similar, right?
Yeah.
So we don't want to change the business logic. We want to keep the business logic as it is, and we don't want to interact with the data also.
Okay. So the data mart focused upon the country's need, or that business specific need. Okay.
Yes, business specific need. That is the reason we are going for the small data mart.
But the data altogether sits in the data warehouse, and it's just
entirely in the data warehouse. And from that, we move it to small data mart.
Okay, so it's like is it like different tables then, or it's like its own environment when you call data mart?
In its own environment, we can call. In another table, for example, here I'm using some table like this. Let us see. HR assignment, some table I'm using here. Okay.
Right.
So this will be in one schema. Let us think. It is in Scott Tiger schema. Let us think. Okay. So when loading the data into this data warehouse, I may load it into another schema. Let us think some target is the name of my schema. Target is the name of my schema. And in the data warehouse, I'm using some table like this. HR assignment is my table here. This is all of a different environment, right? Again, when you're loading to the data mart, you may use some other thing. You may use some other thing like batch 10 is the username and batch 10 is the password. And here when you're loading, here you have another table like HR, assignment, CM, something. It's entirely different. All the three are in different schemas and the tables are also different. It's too early to discuss this much into deep, but you'll understand when we go into the data session. Okay. Just for time being, understand like data mart is something that we are pulling from the entire data warehouse. We are taking it into small components according to the business logic, whatever we want. Okay.
Yes.
Clear?
Yes.
Yeah, clear.
Okay, thank you. So here data mart, we are calling it as HPQS, which we call it as high performance query structure. Okay. So let's discuss about this. Here in data mart, we have two persons called as Inmon and Kimball. We have two persons whom we are calling as Inmon and Kimball. Okay. So Inmon has his own theory what is warehouse, and Kimball has his own theory what is warehouse. design a very large enterprise data warehouse. From enterprise data warehouse design, subject specific databases known as data mart. Design subject specific databases known as data mart. This is what he is telling about Inmons approach about data mart. This is what he is telling about Inmons approach. So what he is telling, first design the same logic what we are implementing in our project. First design a very large enterprise data warehouse, and from this enterprise data warehouse, depending upon your business, start developing your data mart. This is called as dependent data mart. Why we call this as dependent data mart? Because here the data mart development is depending on enterprise data warehouse. Okay, this is called as top-down approach. In top-down approach, the data mart development depends on enterprise data warehouse. Hence, such data marts are known as dependent data marts. They are known as dependent data marts. Okay, they are known as dependent data marts. The same thing what we are doing here. Here we are designing an entire data warehouse, and from this warehouse we are designing small data marts. This is dependent data mart. According to Inmons theory, he's telling like data mart is dependent data mart. As I told you, we have two data marts here, dependent data mart and independent data mart. So what is dependent data mart? Dependent data mart is nothing but if it depends on enterprise data warehouse, we call it as dependent data mart. Fine. So we have Kimball's theory also. According to Kimball, what he is telling is he is asking us to design subject specific or department specific data mart. He is asking us to design subject specific or department specific data mart. Subject specific or department specific databases known as data mart. Okay. So after this, we integrate the data mart to define enterprise data warehouse. So here, this is what he is asking us to do. Design small data mart. From this small data mart, integrate all these data marts into enterprise data warehouse. So this is called as independent data mart.
Chaitanya, question here. Then USA data mart is going to be independent and Italy is going to be a dependent data mart, right? As per this definition.
I didn't get your question.
So as per the definition, the above example, that the USA data mart is going to be independent and the Italy is going to be dependent.
Yes, you're right.
Okay, thank you.
Okay. So here what he is telling is an independent data mart in a bottom-up approach. A data mart development is independent of enterprise data warehouse. This is what we call it as independent data mart. Okay, so these are the two types of data marts we have. As we have discussed, we have two types of data marts, dependent data mart and independent data mart. Dependent data mart means it completely depends. Independent data mart means first data mart will be defined, then we integrate it into enterprise data warehouse. So it depends upon your business whether you have to go for dependent or whether you have to go for independent. That means whether they want to follow the top-down approach or whether they want to follow the bottom-up approach. Generally, we follow the top-down approach in most cases. Only if the business particularly requires that they need to go for bottom-up, then only we go for bottom-up. Okay? Clear? Shall I go to the next topic?
Yes.
Yes. So let's discuss about data warehouse database design. Okay. So data warehouse. Before we load the data into the data warehouse, the structure of the warehouse should be existing, right? So we generally call, like, we extract the data, we transform the data, and we load the data into the target, we generally call. So when we are going to load the data into the target, the structure of the table should always be existing. That means the structure of the schema should always be existing. So here we are going to discuss how the design is going to be. A data warehouse is designed with following types of schemas. These are the types of schemas the data warehouse is designed with. These are designed with the following types of schemas. What are the types of schemas? Star schema, Snowflake schema, Star schema, Snowflake schema, and Galaxy schema. These are the types of schemas the data warehouse is built with. Star schema, Snowflake schema, and Galaxy schema. So for designing these schemas, we have some designing tools actually. We have some designing tools. We have some tools like Erwin Toad. Using these tools, they design this warehouse. Okay. Before we start the project, like, let us think in the initial stages of our project, what will happen? First, we have the client-side business managers. What they give us all the requirements. They tell us all the requirements. So who are the people who will be involved here? We have database architect and we have database architect or data modeler. Anyone can be here. We have database architect or we have data modelers, and we have database analysts as well. So what they do, database architect or data modeler, whoever will be here, they first gather all the requirements from the client side business manager. Okay. And after gathering all the requirements, the business analyst or the data modeler, the database analyst will give us the requirement. They'll prepare some documents and they'll give us, okay, this is the requirement which the client and business manager wants. What the database architect will do, they'll start designing the warehouse. So the warehouse can be any of these three. It can be a star schema, it can be a Snowflake schema, or it can be a Galaxy schema. Before we start discussing about these schemas, let's discuss about two things called as dimension tables and fact tables. So what is this dimension and what is this fact? Let's discuss. Okay. Let me give you a very simple example. Let us think I have some tables here. Customer is one of my tables. So in every table we have a primary key, right? Let us think we have customer key, which is a primary key. Okay. So other information regarding the customers will be here, like customer ID, customer name, customer address. All the information regarding the customers will be here. Customer name, customer address. All the information regarding the customers will be in this customer table. Fine. Similarly, we have another table called as calendar table. Let us think. Dim underscore calendar is another table. Let us think. So we have some information in the calendars. Like here also we have a key called as primary key, date key, which is a primary key. So all the information regarding the calendars will be here. Like what is the year, quarter, month, week, date. All the information regarding the calendar will be here. Year, quarter, month. In a year we have 4 quarters. In quarter we have 3 months, whatever it is. We have 4 weeks. We have 30 days. All the information regarding the calendars will be here. Similarly, let's take another table called as product table. Let us think. Dim underscore product is another table. Let us think. So all the information regarding the products also will be here. Let us think product key, which is a primary key here. Okay. So here we even have some columns like product ID, product name. All the information regarding the product will be here. Product ID, product name. All the information regarding the product table will be here. Similarly, let's take another table like market table. Let us think. So all the information regarding the market. Since every table should have a primary key, we have a primary key here, which is market key, which is a primary key here. So all the other information regarding the market will be here, like the country, region, state. All the information regarding the information regarding the markets will be stored in this particular table. Okay. So here, before proceeding with this, are you aware of primary key and foreign key concept? Primary key and foreign key concept.
Yes.
What is primary key? Primary key is something like it should be unique and there should not be any null values. The values, whatever we are taking, it should be unique and there should not be any null values. And foreign key is nothing but it's a reference of a primary key. Reference is a primary key. Reference is a primary key. The foreign key, whatever we are taking, it will reference a primary key. For example, let me show you. If we just log in into our Oracle database, we have some Spot Tiger default schema here. Let's log in into that. Okay. Okay. So here let us think I'm selecting two default tables. EMP is one of the tables and DEPT is one of the tables. I'm selecting two default tables. Okay. So if we observe the structure of DEPT table, this DEPT number is a primary key. That means it should be unique and there should not be any null values. See, this department number, whatever we are taking in DEPT table, the value should be unique. There is no repetition of value and there is no null value also. So that is what we call it as primary key. Primary key is something like there should not be any repetition of values and there should not be any null value also. So if you're having a primary key, there must exist a foreign key. We will always have a foreign key. Foreign key is nothing but it's a reference of a primary key. It's a reference of a primary key. Whatever the column values we have here, that means for department number we have 10, 20, 30, 40, 50, 60, right? Only the same values can be in foreign key also. Only the same values can be in this foreign key also. It can't have 70 because department number is not having 70. It can't have 70 over here. This is what we call it's a reference to a primary key. Foreign key is nothing but it's a reference to a primary key. Always the data should first get loaded into primary key, then only the data can be loaded into foreign key. Then only the data can be loaded into foreign key. Okay. So the same concept applies here in our Informatica also. So we are having a primary key. See here, if you observe the tables, whatever we are taking four tables here. DIM underscore customer is the customer table. DIM underscore calendar is the calendar table. DIM underscore market is the market table. DIM underscore product is the product table. So for every table, we have a primary key to observe. For every table, we have a primary key. What is primary key? It should be unique and there should not be any null values for the primary key. Fine. So when we have a primary key, we will always have a foreign key, right? So we always have a foreign key. So in between, we have a foreign key here. We have another table called as transaction fact table. We have another table called as transaction fact table. So here, for this table also, we have a primary key. That is transaction ID, which is a primary key. Transaction ID, which is a primary key. So all the foreign keys will be contained here. Customer key, foreign key will be contained here. Since we have the primary key here, so customer key, foreign key will be contained here. Customer key, foreign key will be contained here. Date key, foreign key will be contained here. Date key, foreign key will be contained here. Product key, foreign key will be contained here. All the foreign keys will be contained here. Similarly, market key, foreign key will be contained here. All the foreign keys will be contained here. Okay. So this is what we call it as dimension tables and this is what we call it as fact tables. If we just observe, we can observe like what is dimension? Dimension is nothing but it contains all the descriptive data. The complete information about the table is contained in the dimension table. So if someone asks you what is the dimension table, then you can tell dimension is nothing but it's a descriptive data. It contains all the descriptive information regarding that key performance indicators. It describes the key performance indicators are known as facts. Okay, so if you observe here, product ID, it is a numeric data. Will it contain in the fact table? No. Customer ID is a numeric data. Will it contain in the fact table? Weeks, like we have 4 weeks. So, will it contain? No. The facts are numeric, but what are the types of things it contains? It contains only the numerics which describes the key performance indicator. See here, market key is a key performance indicator here in dimension table. So, we have the market key, foreign key here in the fact table. So, this is how we differentiate between the dimension tables and fact tables. So, as per our scenario, first the data should always get loaded into dimension table, then the data should get loaded into fact table. Okay, so we generally call dimension is nothing but it contains all the detailed information regarding the table, and fact table will always contain the summarized information regarding the table. Okay, so coming to our star schema and snowflake schema. What is the star schema? Star schema is nothing but if it contains a centrally located fact table surrounded by multiple dimension tables. Since the design looks like a star, we call it a star schema database design. They call it a star schema database design. Okay, so if we speak about star schema is nothing but in star schema is a database design. It's a database design which contains a centrally located fact table, centrally located fact table, surrounded by multiple dimension tables. Since database design looks like a star, we call it a star schema database design. Here, any questions as of now? Any questions, anyone?
No.
No, I'm fine.
Okay. So this is what we call it a star schema. So the data warehouse is designed with any of these 3 types of schemas. So before we start the project itself, these schemas will be designed. That means whether the dimension tables and the fact tables, the structure will be defined. Our job is just to load the data into the dimensions and load the data into facts. These will be designed by database architects. They will design whether they go for star or whether they go for snowflake. It depends upon the database architect. They will design these tables. The structure of all these tables, they will be designing it. And our job is just to load the data into dimension tables first, then to load the data into fact tables next. Okay, so this is called a star schema. In star schema, what's happening? First, it contains a centrally located fact table surrounded by multiple dimension tables. Since the design looks like a star, we call it a star schema database design. Okay, similarly, if you go for snowflake schema, what will happen? The second schema, snowflake schema. What is the snowflake schema? See, in snowflake schema, a denormalized dimension table is splitted into one or more normalized tables. A very large dimension table needs to be splitted to save a quite bit of table space. In snowflake schema, dimension tables are parents. In snowflake schema, dimension tables have parents. Let me tell you what tables here are denormalized. The dimension tables here are denormalized. So when we are coming to Snowflake schema, what we'll do is the dimension tables, whatever we have, we are going to split it into one or more normalized tables. For example, if you're having this dimension table, exim underscore market, let us say, this will be splitted again, like exim underscore market 1, dim underscore market 2, like this will be splitted. Why we generally split it? To save a quite bit of table space. To save some table space, we split it. And here, in one dimension to another dimension, it will have a relationship. It will have a relationship. That is the reason we call it as in Snowflake schema, dimension tables are parent. In Snowflake schema, dimension tables are parent. So similarly, the other thing can be like this product table, market table, or a time table, whatever it is. Quality table, something. All the dimension tables will be here, and the fact table also will be here. And the fact table also will be here. The only difference between between star schema and Snowflake schema is in Snowflake schema, the dimension tables, whatever we have, we will split the nice dimension tables into normalized tables. If we have a very big dimension table, this will split all those dimension tables into small normalized tables. So why we do this? To save a quite bit of table space, we split it into normalized tables. And in Snowflake schema, the dimension tables we have parents. One dimension table is dependent on another dimension table, so it will have some parents. Snowflake schema, the dimension tables are having some parents. So this is the difference between star schema and Snowflake schema. Okay, someone asks you like what is the difference between star schema and Snowflake schema, you can just give these differences. Star schema, Snowflake schema. What is star schema and Snowflake schema? In star schema, the dimension tables are denormalized. These are denormalized. In Snowflake schema, the dimension tables are normalized. These are normalized dimensions.
But you said other way around.
Dimension tables does not have parents.
Chaitanya, you said other way around. Star schema, you said normalized. Did you see your?
Here, a denormalized dimension table is split into one or more normalized tables.
Oh, okay, sorry. Okay, I thought it's a definition. Okay.
No, a denormalized dimension. A denormalized dimension itself in star schema, we have a denormalized dimension table that is splitted. You can say denormalized is this one and normalizing is this one, making it into small components. That is what we call it as normalization, right?
Right.
And dimensions does not have parents. Dimensions does not have parents, and here dimension tables have parents. So this is the difference between star schema and Snowflake schema. And coming to Galaxy, Galaxy is nothing but it's a combination of star and Snowflake. Galaxy schema is nothing but it's a combination of star and Snowflake. It can be a combination of star schema and Snowflake schema, or it can be a combination of Snowflake and Snowflake. That is what we call it as Galaxy schema. Combination of Snowflake and Snowflake is also we call it as Galaxy schema. Okay, so using any of these three types of schemas, like they may design these schemas, they may create. Designing the schemas are nothing but designing the structure for the table. Designing the structure for the table. They design some tables like this is a dimension table, this is the fact table. So your job is just to load the data into the dimension tables and to load the data into the fact tables. But from the database architect point of view, he will design whether it's a star schema or whether it's a Snowflake schema. Okay? Here, what is the difference between star and Snowflake? In star schema, we have a centrally located fact table surrounded by multiple dimension tables. So the data will always be loaded into dimension tables, then the data will be loaded into the fact tables. But coming to Snowflake schema, the dimension tables are splitted. They are splitted. So here also first the data will be loaded into dimension tables. If you are trying to load the data into this, first the data should be loaded into this, then to this, then to this. Right? So in Snowflake schema, the denormalized dimension table is split into one or more normalized tables. Galaxy schema is nothing but it can be a combination of star schema plus Snowflake schema, or Snowflake schema plus Snowflake schema is what we call it as Galaxy schema. Okay? Any questions as of now?
this denormalized, is it like, let's say, the first example where it was star, and you have a product? Is it like the products are not in a normalized fashion? Like, I'm trying to understand it, okay, from example standpoint. So if you have a product, and is it not normalized in a way that should be? So is it mixed up with multiple attributes?
No. For example, let me give you a simple example. If I take something like EMP table, let us think. Okay, let us think this EMP table. So we have some data in this EMP table. Fine. So this is a form of denormalization, let us think. This is normalized, let us think. We are not going to make it into small components. For example, if I want to make this into small components, what I should do is I should create another table that is EMP1. I should create another table that is EMP1, and it should have a relationship. And it should have a relationship with this DEPT number, which is a primary. It should have a relationship with this. Okay. Why we generally do this is to save some table space, we split it and to decompose it.
Okay, so to improve the performance.
Yes, for increasing the performance size, we split it.
Okay. So it's not certain columns goes to one table and not. No. Okay. So it's
That's
the row.
certain.
It's the data that drives it.
Yes.
Okay.
Let me speak about the next dimension, which we call it a slowly changing dimension. One form of dimension, which we call it a slowly changing dimension. This is one of the dimensions which we are going to implement. This is the mostly used dimension, slowly changing dimension. A dimension which can be changed over the period of time is known as slowly changing dimension. A dimension which can be changed over the period of time is known as slowly changing dimension. Okay. Let me tell you what are the slowly changing dimensions. Here there are three types of slowly changing dimensions. There are three types of slowly changing dimensions, which we call it as SCDs. They are type 1 dimension, type 2 dimension, and type 3 dimension. Type 1 dimension, type 2 dimension, and type 3 dimension. These are the three types of dimensions which we have. And type 3 dimension. Okay. So what is this type 1 dimension? Type 1 dimension is nothing but a type 1 dimension keeps only current data in the target. A type 1 dimension keeps only current data in the target. It keeps only current data in the target. It does not maintain any history in the target. It does not maintain any history in the target. Any history in the target. I'll explain. See here, for example, this is my source, let us think. I have some columns in my source. Employee, number, name, salary, designation. These are the columns I have in my source. The same columns I have in my target also. Target is a dimension table, let us think. This is a dimension table. Employee number, name, salary, designation. Fine. Let us think employee number 786. Let us think his name is something like Smith. Salary 1000, designation software engineer. So the same columns will be moved to the target as well. 786, name will be Smith, salary will be 1000, designation will be software engineer. So this is called as type 1 dimension. This is called as type 1 dimension. That means for each update that is taking place in the source, it will insert the same record in the target. And it will update also. For example, if the salary is becoming 2000 and his designation is becoming senior software engineer, what will happen? This is a dimension table. So in the target, it will automatically get updated here itself. So what I mean to tell you here is a type 1 dimension keeps only current data in the target. It just keeps only the current data. It does not maintain any history in the target, in the dimension target. But coming to type 2 dimension, a type 2 dimension keeps complete history in the dimension table. A type 2 dimension coming to type 3. What is this type 3 dimension? A type 3 dimension keeps partial history. That means it keeps current and previous information both. A type 3 dimension keeps current and previous information. It keeps current and previous information in the target. It keeps current and previous information in the target. That is partial history. That is partial history. That is partial history. It keeps the current and previous information in the target. Partial history. For example, let us think our organization is established 30 years back. 30 years back. So all the 30 years information will be in this type 2. Because type 2 is storing the complete history, it will contain all the 30 years information. For example, let us think I wanted 2 years or 3 years information, then we go for this type 3 dimension. Then we go for this type 3 dimension. We keep a current as well as partial history, not the entire history, but partial history in the target. So we call it as type 3 dimension. So using any of these dimensions, we are going to load the data into the target table. Whether by using type 1 or type 2 or type 3. Mostly we use either type 1 or type 2. We will not go for type 3. Okay, if you want to show the current information, we go for this type 1 dimension. If you want to show the complete historical data, we go for the type 2 dimension. But in next cases, we go for the type 3 dimension. Okay, clear?
Yes.
Any questions? You want to
The same rule can apply for fact tables too, is it?
See?
Can the same rule apply for fact tables too?
No. Fact table is different again. Dimension table is different and fact table is different again.
So you cannot use the same concepts in the fact
You
table?
cannot use the same concept, yes.
Okay.
In fact, what we are doing is, after all these are successfully completed, that means after all my primary keys and all the data is successfully loaded into dimension table, I just use one key, that is foreign key in the fact table, that is the aggregated values, and we'll just directly load it. In fact, we don't apply any of these concepts. It's a sort of direct loading into the fact table. Okay?
But the fact table will also have historical data, right? I mean,
yeah, it can have the historical data, but we won't apply a business logic as of such, how we apply in the dimension table.
all right, okay.
For example, this is something like type 2 dimension, this is something like type 1 dimension. These are the dimension tables. Using different business logic, we are loading the data into the dimension table. Okay, so after all these dimensions are successfully loaded, then we go to the fact table, which is a direct load. So let us think this is the case. These are the dimension tables. After these are successfully loaded, then we go for the fact table. Discussing the theory part may be a little bit confusing, but once we start implementing the practical, you can clearly understand like what is this dimension, what is this part. You can clearly understand. Since it's the theory part, you may get a little bit confused, but when we're discussing about the practical part, you can clearly understand like what is this dimension table, what is this fact table, what is this SPD type 1, type 2, different methods, so what are the different types, everything you can understand. Okay? I think it's enough for today. Like too much of theory we're discussing today. It's enough for today. And the next session, I would like to discuss about the power center components. Different power center components we have here, right? So I'd like to discuss those power center components in the next session.
Chaitanya,
So that is the practical part. Yeah.
did I miss the topics 3, 4, 5 OLAP and OLTP, and it's been covered already? Data warehousing architecture.
We'll cover those topics once these are completed. The database basics are completed, then we'll start covering those topics.
Okay, OLAP, OLTP, those topics is it? Later, okay.
Yes.
Okay. Yeah, I just see the, okay. Okay, thanks.
Okay then. I think it's enough for today. We discussed too much of theory today. And in the next session, we'll discuss the other topics. Okay?
Yeah, but Chaitanya, please send the notes. Otherwise, it will be too much in the later stage.
Yeah, I'll forward.
Yeah, because I will get at least notes so I can go through in the deep for each, whatever the points you are right.
Previous session's notes. I forgot
Yeah.
it actually. I'll forward it to Naren and I'll ask him.
And then like book like some simple kind of like book to start data warehousing and this one. If you are aware of.
I'll forward you some documents. Those are more than enough. I'll forward you some.
Yeah, I mean whatever it is. Just send.
Yeah, I'll forward some documents.
Because I'm totally new to this also. After your session, if I will get some times I can go into the deep and can learn.
Okay. I'll forward some material which I have with me.
Chaitanya.
Regarding this software installation, this Informatica, so Naren will help, or like you are going to help, Chaitanya?
Anyone like he told me that he's going to forward. If he's not going to forward, in the next session I'll forward it.
Yeah, I got it. We downloaded the software.
Oh, you downloaded it? Then I'll do it. One session I'll do the installation part.
Yeah, okay, that would be great. Like we can have during the session.
Yes. One session I'll do it so that if I do for one, all others can follow the same process.
Yep, that would be nice.
Chaitanya Kadir here. I'm just thinking. So you are always covering the typing the information, or you don't have like a presentation like already PowerPoint prepared kind of thing.
Yeah, Kadir, generally why I don't prefer it is I feel like it's good if I type and same like classroom teaching, right?
No, that's correct. But if we need to refer in future, so there is no material. What kind of?
I have some documents. I have those documents already prepared. I'll forward those documents.
So each and every session documents you already prepared document you have.
Yes, I have all the documents already prepared. Is there something like this for your understanding? I'll write in a notepad and I'll just forward that notepad to you.
Okay. So the entire course is going to be like this only. So you are going to just sending the notes and every time all after finishing the class.
Yes.
Oh, that is the material, is it?
No, not this material. Other than this, I have another material with me.
Oh, okay. We have another material. Okay. Okay. So yeah. So for the future reference, we need a material. That's what I mean. So. Okay. Thank you.
I have another material. I'll forward that material once the sessions like 2 to 3 transformations are over. I'll forward them.
Yeah. Sure. Thanks.
Send these notes, Chaitanya. These one, whatever you are typing, that will be great help.
Yeah, like Kadir, like how I feel is if they are very new to data warehouse, this will be a really helpful for them.